feel free to.
Hello everyone, I'm Emma and I'll be there as tech support during the tutorial. I want to introduce you to our tutor Isidora Gataric. She is a senior data analyst at the Jagger and she will hold the Analyze Your Data in Python tutorial. Enjoy.
Hi. Well, we can start. I don't know actually what knowledge you have about Python before this course, but I will try to introduce you to data analytics in Python from scratch. Most courses actually are focused on machine learning, NLP, and more advanced techniques than data analytics per se and statistics. So I think that this will be useful for you if you use it in everyday job or in academic purposes or something similar. I will share my screen. Give me just a second to find a button. Okay, share screen. Host disable me to share the screen. Just to see where is my host.
I'm here. Sorry. Ajde ovako, znači ja ću ti staviti da budeš host, ali to znači da ja neću više moći da pišem u chatu ništa što će da vide učesnici. Tako da šta god da treba da deliš, samo stavi da šeruješ sa svima.
Deal.
So I will make you a host. Just a second.
While we're waiting, you can go to the link in chat, and you can download the CSV and Excel files on desktop. And you also have a code in Python. Actually, it's in Jupyter Notebook file. And you can also download that. That's the code we will use today. I will go step by step through the entire code. But if you are faster or slower than me, you can follow the code and copy paste the codes, the line of codes.
I think you can share screen now. I've made you host.
Yep, I can.
Okay, good luck.
Thank you. Okay, I hope you can see the screen. If you have any questions, I can see it when I'm sharing screen, but I will check in chat, or maybe sometimes I will open the chat. Please type, or after the presentation, if you have anything. There is no link in a chat. Okay, maybe you can see it. Maybe we send one to each other.
You share the link with host and panelists. You have to switch to everyone.
Sorry, my mistake. Everyone. Okay. Now I think you can.
That's fine.
Okay, sorry for this. So, first of all, as you heard, I'm data analyst, and we are more focused to preparing the data for the more advanced machine learning, NLP techniques, deep learning, and things like that. And we actually use the data to describe the situation in data set, or we conduct some inferential statistics methods to compare something. Also regression. Today I will focus my attention to linear regression only, because all other types of regression are more advanced techniques and are more related to machine learning than to data analytics. So you have some advanced courses on this conference, so you can follow that for more details, but today we will focus on this. So all the data sets you have are data sets created by me, and they're fake. When I say they're fake, they're not realistic data sets, and we are using it only for training purposes. So you can use it for everything you want, and maybe there I found already some mistakes, and I will I will edit it and send it to you after the presentation. But we will start. So I don't know how you are familiar. How much are you familiar with Jupyter Notebook? I can open to see. Okay, some questions. But I hope you are. So I will go direct to the code. First step in data analytics in Python is data preprocessing. Before we conduct any preprocessing, we need to import the packages in Python. I think that all those packages you have already installed, maybe Plotly not, but you can install it. Install pip install package, something like that. I will type here for those who are not familiar with that. Install Plotly. But I think that all others you have by default in Jupyter Notebook. We are mostly focused to pandas, and Seaborn, Matplot, and Plotly are mostly used for visualization, which is a huge part of our job. And first thing, I will run this when I import the packages. It's extremely important because without packages, your codes will not work. After that, I will load dataset. This is dataset we will use today. I will explain it a little bit later. What data you have there, for what you can use it. I created that dataset for you to have a different type of the data. Practically all that you will meet in data analytics, categorical data, numerical data, I think that's all we have here. Floating, yes, we have some floating points and things like that. You will see when you import the packages, you need to load the data set. We will use this function for that. This is from pandas package. Read Excel is mostly used when you're actually you can use it only when you're using Excel data set. When you're using, for example, CSV file, you will write here CSV instead of Excel. Or if you're using JSON, you can write JSON. It depends on you. We will focus our attention today on Excel. So when you type this line of code, this is the path where you store your data set, and you can run this. I think it's much easier if you download the code. You can open it in Google Colab also, so you can copy paste the code instead of typing, because I think that you will need a huge amount of time if you type every letter. So it will be easier for you to open, for example, in Google Colab and to copy paste my codes while I'm explaining. Once when you are loading the data, you will know that you're loaded properly if you have some output like this. And you will have the information about the number of rows and columns. I will check just a second. Do you have any question? No. Okay. So once when you are loading the data, it's very important for you actually to inform about the columns you have and to list all the columns you have, and practically those are the features you will use in a data analytics process, or even later if you are conducting your analysis in machine learning or deep learning or some NLP analysis, if you're interested in that. So those are the data and the features we have in this data set. This data set is practically, I imagine it like something fake data science, data camp platform with the information about the courses related with data science. And those are informations about that imaginary course and imaginary platform. Once when you are informed about the features you have in your data set, it's very important for you to check the other information, relevant information for your data. For example, the type of the data. It's very important because if you have some I can say some data type that you cannot use, you can change the data type, actually transform the variable. And it's extremely important for you once when you are in an inferential statistics part of the data analysis, you can decide which statistical test you can use. And it's extremely important for you if you have something to change to detect here in this step, and then not to conduct the entire analysis and after that to realize that you have some problem, issue, I can say like that. And after that you will have to run again the entire analysis, and it's not necessary. So it's easier for you to check the type of the data here. Also, you can inform here about the non-null counts and non-null values, to be more precise, and you can inform about the amount of the data, although you can see it here also, but it's better for you to inform more than once and to be sure about the data you have. So if you're interested only in the data type, and for example, you forgot this function, you can do it with this function. You see that I put everywhere IG. You can type another letters, so it's not related with the code. So that's the name of the data set. Data frame I created here from the data set I use. So you can change that. IG is not a part of the function. So for example, you can type, I don't know, beauty point data type, whatever you want. So if you want to check your data set and what you have in data set, this is a very good function for you. You can just present the head and the tail, top 10 or top 3, top 9, etc. Especially this is a very, very good function if you have a huge amount of data and if you have a large data set, which is almost always in real life. This is training, and this data set is extremely small, but in real life, it's not so easy to find such small data sets. So this will be a good option for you because you will not need to present the entire data set and to use all the data that you have. So once when you are done with loading the data and you are informed about the data type you have, you can actually pre-process the data set. You can do anything you imagine with data set. I put only few functions here, and in a code I will give you after the training and after the presentation. I actually put some additional information that maybe will be interesting to you, and some additional links to the pandas functions. You can literally play the entire day with the pandas and it will not be enough. So I just select a few functions here. One of the very, very common use function is rename. So if you have, for example, some column that you need to rename in dataset, and you don't want to do that in Excel and CSV and JSON because it's not good to do that. It's much better to do it like this. So you can rename it with just this function. This is the original name of the column, and this is the new name of the column. Practically, those two names will be separated with two points. I don't know. Do we have some better word in English? But this is the separation sign in this function. So you practically define the present state and how you would like to rename the column. This logic is very often used in Python, just to know. So it will be good to remember that you can, that some separation you can use with this. I will just check the, okay, some questions. Thank you for writing this in chat. Yeah, if you don't have Matplot and Seaborn, you can install it like that. Okay. So some other functions also then you can use, and it's very good in data analytics, because in data analytics we actually try to realize what we have in data, and sometimes we use a lot of subsets, we can say it like that, just to observe some specific cases. Like for example here we select only male users just to see how they actually behave, I can say like that. And it's very often in real life that you will actually have something similar to do at your daily job. So this is a way, the easiest way you can create the subset. Practically in data frame you can how to say locate the variable you would like to use as a select variable, I can say like that. So practically if you want to create to select only male participants, you can use it. You can use this function. So the logic of this function is please locate only male participants in variable sex from the data frame ig. So you will have here only male participants, users, sorry, only male users, and you can see that the number of rows are lower than the entire data set. So you're sure that actually you work on a subset. All functions that you can apply on data frame on data set, the entire data set, you can apply it also on subset. So this is one of the example. So you can use info function on male subset, or you can use a d-type function on male subset also, and it will work identically. So if you want, for example, to select, or just to list, not to select, that would be a much appropriate term, to list all the field of study and work, I put just first as a reminder. This variable, field study and work, actually describe industry you're working at, or the type of the, how to say, category of the faculty you study. So if you want to list only, to list unique values, just to be sure what structure of the sample you have, you can use it like this. You can use only this line of code. It will work properly, but you will not have separate output separated like this, row by row. So you will have it in one row, and that's not good for the presentation. The view is better like this. And this is a type, this is a part of the code that you can use it, another line of code, just to separate each row and to have a more beautiful presentation of the output. So once when you're done, you can see that only the names, unique values from that variable is listed. But for example, if you're interested also in counts and to see how much in each category, how much cases you have, you can use it. You can use this function. If you want exact numbers, and if you want percentages, you can just add normalized true in bracket, and here you can you have to multiple with 100 just to be sure that you will have a percentages. So I think that logic is clear here. Let me just check chat. Sorry for this interruption. Can we use the method with pandas to check multiple tables and Excel file? You can. You can use it pandas on multiple tables and Excel file. It depends on you. So practically you can merge multiple Excel files and multiple CSV and multiple JSON files. You can merge in a one data frame, and you can conduct practically you can apply all the functions on that data frame, or you can use at each file Excel or at each Excel file and CSV file you can use any of the pandas function. So the answer is yes. You can use it. If you ask me for an advice, I will always advise you to merge multiple data sets and multiple Excel files into one data frame. I think that that will be easier for you to follow the logic and to pre-processing the data. And especially when you come to the later stages at data analytics, to descriptive inferential statistics, predictive statistics, it will be much easier for you to use than to import each files as a separate file. So you can apply also some other functions. This function has some issue, and I realized that a few weeks ago, and I realized here that I didn't I didn't leave a comment, so I will do that in a version I will send you. This is a way that you can present actually and detect the maximum and the minimum value in one data set for the specific variable. And this is the function that you can use it. This is the function for maximum, and this is the function for minimum. And to be honest, I will recommend you to do it a little bit different. We will see later in descriptive statistics. But if you are in a hurry and you need to detect minimum and maximum now, this is the easiest way to do that. So if you use this function, you can see the maximum value for age, for example, is this amount, this count, and this number, and you can see that this is mistake. So you're now sure that you have some outliers. We will talk about outliers and extreme values a little bit later, and that you need to clean the data set before you do any statistics and data analytic per se. The identical situation is here. So when you have a user with age 1, you know that you have some mistake in data, and it's you need to clean it. Actually, this is a good way, or I can say this is it's not a good way. It's a good first step if you want to be sure that your data is okay, because you don't in real life you will never meet clear data or good or very good data. You will just see some data with more or less issues, and that's reality. So this is a good option for you if you want just to check fast what you have in your data set. Also, if you're interested in to some nonce or missing values, this is also a very good option. Missing values are big issue, I can say like that, in almost every data set you will use. And my advice for you will always be to extract it from the data set. I know that in some situations you cannot do that, especially if you are academics and you work with a smaller amount of data, for example, in medicine, pharmacy, with some similar disciplines. So you have extremely small amount of participants or users, and you're not able to extract anyone. So there is some different methods that you can practically replace nonce with the average values and things like that. But I will not recommend it. If you have a big enough data set, my advice for you will be to extract all the nonce and nulls, because they will definitely affect your distribution. And in statistics, in data analytics, the distribution is, how to say, the first thing you will have to take care of. So I will back on the code. This is the easiest way to sum the nonce or the missing values for each feature or variable you have in a data set. So you can see, for example, here that you have 9 missing values in the sex variable, or you have a lot of nonce, almost not a half, but a little bit smaller amount than half in the number of purchased courses. So you're sure that some of the variables you have are problematic and that you will definitely need to clean it and to extract all those values, and we will do it a little bit later. So if you're, for example, want to sum the nonce only on one specific variable, for example, you are expert and you are sure that some of your variable could be very problematic, this is a good way to do that. The easiest way to drop missing values is this one. So practically the logic of this code is to create a new data frame where you will not have nonce. This is the logic. Okay, create new data. You use IG dataset, drop NA from IG dataset, and create a new data frame. That's the logic you can follow here, and that's the logic you can follow in most of the Python packages, pandas especially, but you can drop the NAs. Give me just a second to check chat. Okay. I see the question. They don't calculate the maximum and minimum for string fields. That's why I'm said that that function is problematic. You will see later in descriptive statistics we have better option to do that, and we have part of the code where you can actually detect for the string the minimum and the maximum. I can say like that. It's not minimum in a maximum in mathematical way. It's the smallest. It's the category with the smallest amount of cases and the category with the largest amount of cases. More advanced algorithm. I will back on that. So. You can drop NAs, and practically you will work only with a clean data set. I can say like that. You can see that you have an extremely smaller amount of rows. Once when you extract all the nonce, you can notice here that we extracted practically all the nonce we detected in some previous steps. And if you want only, for example, to extract the nonce from one specific variable, this is a good option for you. You can save it as a different data set. You can save it in the data set you're using for some other analysis. It depends on you. And also, you have the possibility to save in a separate data set only values that are nonce. It could be interesting for you if you have some business question related with that, and for example you would like to detect the features, more problematic features, and more problematic customers, users, participants. It depends of the business or research question you have. This is also something you can see in how I can say in literature. But I will not recommend you to do this, especially in statistics. You can fill NAs with nulls. This is extremely problematic. Once when you came to distribution, you will realize why. So I will not recommend that, but I need to put this in this code because it's used very, very often. And you will see a lot of recommendations from the people in the industry to fill NAs with zeros, which I'm not a fan of. So just be careful. If you decide to do this, just think about the meaning of that zero. Once when you are feel practically you will you add non-existing value to the missing value, because zero in this case is not real zero. So just think about the meaning of that zero in your data set, and you will be, I think, very aware of the fact that that is problematic. If you want to replace ordinance with 0, you will practically do nothing. And again, you will have to extract those zeros here in this part, in this step, when you remove the extreme values and outliers. So I'm not sure that that's a good way. Now we are here in just to summarize the previous steps. Till these steps, practically all the previous steps are more related with preparing data for the more advanced pre-processing. And you have data set of, okay, you can rename the columns, you can extract the nonce, you can maybe delete some columns and rows. It depends on you, and maybe you realize that you don't need any some columns anymore. So you prepare practically the data set for the more advanced pre-processing. More advanced pre-processing is related with this removal of extreme values and outliers, and in this step you are more focused to how to say to create, I can say like that, some more specific hypotheses that you will test later once when you are doing statistics. So removing of extreme values and outliers is the most important part, in my opinion, is the most important part of pre-processing, especially for us who are working a lot with the numerical variables. And I think that all of us in this chat work with numerical variables, no matter which field of interest we have and where we are working or studying or whatever. So you have to exclude the extreme values and outliers in on actually numerical variables if you want to use it properly. This is extreme values and outliers are problematic because your distribution of data is not close to the normal Gaussian distribution. And practically all statistical tests we have and are widely used have that as a premise. So they all follow the idea that all data and all numerical features are distributed normally, and it's not the case. So you need to remove extreme values and outliers just to clean your feature and to close their distribution to the normal Gaussian distribution. Difference between outliers and extreme values is that outlier is some non-existing value. It's not realistic, and extreme values can be realistic. So just think about that, and we can, as the name said, call it extremes, but it can be measured and it can be realistic. This is the first way. I put here only the two ways we are using mostly in industry. Actually, to be honest, the two ways that I meet during my career. And this is the first way when you don't have time, and maybe you can use it more often once when you're expert in some field. But to be honest, I don't recommend it. The next one is more precise and goes in more details, and I think that it's extremely important to be here very, very careful what you extract. But this is the first way you can use it. First step is to draw the box plot for the. I took this numerical feature. So draw the box plot and take a look how it looks like, and where you can where you can detect some border between the extreme values and outliers, those dots here, and the values that are how to say, in this this part of the graph, where actually are the normal distribution. This is the mean, and those are values close to that values. So once when you detect the border where you can draw the line between the values and the extreme values and outliers, you can exclude all the values that are higher than that or lower than that. It depends where you look, where you take a look to the right or to the left of the mean. This line is a mean. So Once when you detect that, also you can draw histogram, sorry, I forgot to mention that. Box plot, it's much better, and I think that you can detect the values you need to extract. It will be more, maybe visually, it will be more easier to you to realize where the border is, just by look. So this is a border. And here, in histogram, I'm not sure that you can see it at first look, but you can also write histogram just to be sure that the border is something on some similar account. I detect that the border is 117, and I will exclude all the values higher than that. So the logic of this line of code and this function is to save everything lower than that in the data frame. So you can realize and you can notice that this logic we had already. So this is a logic that we actually use in Python when we try to create some subsets that are cleaned or something like that. So once when you do that, you see that you have a smaller amount of data, and also you can do that for the left part of the distribution. I will back to the zeros I mentioned before. So you see that here practically a 0 is the border, if you say by look. We will see later in a few seconds and minutes how it looks like when you actually calculate that the lower border, and then the number you have it as a border number. But just here, if you just take a look and not think about that, you can conclude that the 0 is proper measure and that you don't have to exclude any zeros, and that zeros are informative to you. But no. So the situation is different. And we will see how we can calculate that. I will just take a look on chat. Okay, no questions. Okay. So the better way, and in my opinion, the more precise way, and in general, we use this way when you have time, and I strongly recommend you to focus on this, is to actually draw the percentile range on 25 and 75 percentiles, and to exclude all the values that you have higher and lower than that range. Practically, you will calculate mathematically the range and exclude everything that is not in that bracket. So this function it's written by me and my colleagues. You don't have it in any package. Of course, I will share it with you, and you can use it anytime you need it. It's not mine per se. We just wrote it for our project because I don't know why. I'm not sure. I don't have explanation and the answer. But in none of the package I mentioned above, they don't specify the percentile function, which is strange, but it happens. So here you actually, in this function, you define which variable you will use. You define that you will need percentile rank, that you need to split it in four parts, and that you need to sort values and to detect the number you have on 25 and 75 percentile, and that you will need to exclude everything higher and lower than that. The first step will be to exclude everything lower than 4. So I will back you again on the theme and topic about zeros. You can see now that 0 is very problematic, and if you fill the NAs with zeros, you will practically again exclude all the values here, because 0 is recognized as the extreme extreme value or to be more precise, non-informative value in this case. So if we take a look on the higher border number, you can see that it's much lower than we suspect and that we view actually in a previous way when we try to detect the extreme values. So now it's 59. So you can exclude everything higher than that. This is the line of the code. You can use it to exclude everything higher than 59 and lower than 4. And here you can see, oh, sorry, this is the graph that you can actually use, histogram, to present the values before you exclude everything. You see that's identical like the one we had before. And here is the graph you can use and draw, I can say like that, when you exclude the values detected as extreme values and outliers, just to see how the distribution looks like now. So you can see that it's different. It's still not the normal Gaussian distribution, but it's much closer to the normal Gaussian distribution, and you don't practically have some uniformity like you have here. So you can be more, how to say, precise once when you're doing statistics again, and still you will not, you cannot use the test parametric statistical text. We will discuss the tests, sorry, we will discuss that, but the conclusions you will make it on this data will be more precise, I can say like that. So once when you need to do that, I because we're limited with the time, of course, and with the amount of topic I can explain to you, this is only one variable as an example. But once when you are in a data set, you have to do this process of excluding extreme values and outliers practically at each feature, numerical feature. And only in that case, your data set is ready for some statistics, just to be careful about that. So I will check before I continue. Okay, we have some questions, just to be. Okay, thank you. I see that someone wrote. Yes, you can also do it like this, but I think that this function we create is more in my opinion, it's more logical. But of course, you can do it like this here. Cool. You have another way to do it in pandas. Descriptive statistics. Descriptive statistic is something we use practically to describe the data sets. You will not believe, but some data analytics projects stop here, especially if some business people detect that those projects are not will not gain a lot of money. So in some cases, descriptive statistic is the last stop where we as a data analyst stop. And sometimes we are going further in inferential statistics. If we have hypotheses we need to test, and if we don't have the hypothesis we need to test, we stop here. So this is the data set, another one in the my brain doesn't function. Sorry, it's too early for me. Another one that you have in folder on Drive. So this data set is not mine, and this data set is from Kaggle. So you can check, they conduct some very, very good statistics there on this data set. All the other code is mine, an idea, but the data set is not. So we load the data set and we can list the features we have in data set just to be sure what we can work with. I strongly recommend you always, no matter how good technical person you are, just to take 5 minutes of your time just to take care of the logic of the features you have. What the logical conclusions can be made, how you can set the logical hypothesis. It's not everything in technical, especially in our job. We work very closely to business people and to customers, and it's not always about the best technical solution. Sometimes you need to explain in logic why you do that, why you do something, and what other things you can do, and things like that. So that's my advice for you, just to be very, very patient when you are doing statistics, to have some logical dashboard, or to have some logical analysis, and to have some logical explanation. So as you remember probably, I mentioned minimum and maximum. And this is, for example, I took this variable, order date. This is the way that you can, at each practically feature, no matter if it's categorical or numeric, yes, categorical, numeric, or string, or floating number, or whatever, you can calculate. You can present minimum and maximum. So this is the example of minimum and maximum in order data variable. And this is the function I mentioned before, my favorite function, to be honest, descriptive statistic, because it's extremely easy and you can use it for everything. Describe, and it's very logical. So once when you're conduct this function, you will have the information about minimum and maximum at each categorical feature. And you will have the information about percentiles, remember that, at each categorical numerical feature, sorry. You will have information about mean and standard deviation. One note to you: this function suspects that all the data are represented normally, and that all data are close to Gaussian normal distribution, which is not the case. Once again, I highlighted that. So by default, it calculates mean and the standard deviation, but in a few minutes you will see that we can add some additional parameter for calculating the median, mode, and some other important information. If you want, for example, to describe, to calculate and to have descriptive statistic only for one variable, in dataset you can use this. Practically you can here mention what variable you would like or feature you would like to use. And if you have multiple features, you can use you can write it like that, no matter how much you need. You want to select, practically to select some features and to conduct descriptive statistics only on those features. We had some question about the categorical and string data, and this is the function we can use. The function is identical, but this is the argument we include in a bracket if we want to have the information about frequencies, about first and last mentioned in data set, about the number of unique values, which is the top values, the most often value in or category in that categorical variable. So if you want to have everything in one table, this is option for you. My advice for you will be, if you're doing some descriptive statistics, to split the explanation or on dashboard. If you're creating some dashboard for your business developer or BI business analyst, or for any, no matter whom, to split the tables and to present the categorical and string data in one table, and to present the numerical variables in another one. I think that would be more logical to follow, for me, it will be easier to follow, and the logic is better if you split the information, not to use this extremely big table, but you can calculate anything you want. That's the highlight. If you want to calculate some specific parameters and not to calculate the entire for all the features, to calculate an entire data set, all the parameters, you can use it like that. So for example, if you want to see the sum for sales, this is the option. If you want to see mean, this could be the good function for you. If you want to calculate the standard deviation, this is a good function. Median and mode we're using when we have data that are not normally distributed, especially median. A lot of non-parametric statistical tests are created on median as a measure of central tendency, and it's important for you just to be aware that sometimes you need to calculate both mean and median just to be in mode if you want, but mode is very rarely used, but median will be always my advice for you to check, just to be sure how far away mean and median are one from another. In a situation when you have a normal distribution, perfect normal distribution, or distribution which is normal, which is close to the normal Gaussian distribution, mean and median will be close one to each other. Just to be sure, just to know, sorry. After you finish all those calculations, I can say like that, in descriptive statistic, practically the must is to calculate and to create some graphs. This is the graph. We can use it, for example, to present the sales. It's histogram. If you want to use more detailed histogram, you can include more categorical variables and practically to do segmentations according to some values. Those graphs are plotly graphs, and the reason I included those graphs, in my opinion, they are most beautiful for presentation. You can download it as a photo. You can merge it on if you have some homepage. Somewhere set it. You can present it in a different way. It's those graphs are interactive graphs, and I like that. So this is personal preference, to be honest, and it's not a law. So you can use any other package if you want, but this one will be my recommendation for you. You can, after this course, you can Google it. I'm always in love when I see what type of 3D graphs people create, so this is a great package for the visualization. And something we use very often is a pie chart. It's not my favorite chart, but it's used, so I have to use it too. And this is the way that you can draw that chart. In descriptive statistics, practically it's a law to use both tabular presentation of the data and to use descriptive visual presentation of the data. So both things are important, and descriptive statistics is practically the aim of descriptive statistic is to describe, as the name told us, the situation in data set for all the variables we have. I will check before I continue. Okay, just to see what we have in chat. Why not use it describe? you can use it. It's not the law. If it works and if it gives to you the same results, you can use it. I will always prefer to use something more something shorter, to be honest. So if it works, I never checked before does it work, but if it works for you, then you can use it. You can code practically. This is my personal this code, the one that I'm presenting to you, is the way I'm coding and something that is most logical for me when I'm coding. But you have a million ways to write the identical line of the code, so you can use it any way which is better for you, to say, which is more close to you and more logical to you. But the logic here is something which is not my personal and it's not related with my personal preferences. So the steps here in data analytics process and the way of the presentation is something that we need to follow if we want to have some quality data analytics project conduct. So inferential statistics, once when you are done with the data pre-processing and descriptive statistics, in reality, I have to be honest, it's not so fast. And sometimes we spend weeks on data pre-processing. Here, as I mentioned earlier, we are very limited with the time. So I excluded practically the half of the code I had. And just to fit in time to present you. But as I told you, I will send you some additional materials to play with. And in data analytics, you will be most focused to data pre-processing. And I think, and in my opinion, that's the most important part of all data projects, no matter if you're doing data science or data analytics. If your data are messy and your data are not clean and your data are not logical, you will not you cannot fix it with some fancy algorithms in machine learning and statistics, of course. So once when we prepare the data for the statistics and we conduct descriptive statistic, we can continue to inferential statistics. The logic of inferential statistics is to test the hypothesis, and practically the inferential statistics, we will look at the differences in some numerical variables. For example, you have to set the hypothesis, you will see it later, and to test is it acceptable or not, statistically acceptable, we will see later. So here I described what type of the test we will use. T-test and ANOVA are parametric statistical tests, and Mann-Whitney U, Kraskell, Wallis, Wilcoxon, and Friedman are non-parametric statistical tests. Parametric statistical tests are those that we're using once when we have a good proper amount of data, I can say like that, and when we have a normal distribution or distribution that is close to normal. So we will import the package we will use. I think that only this package could be problematic. Eventually this, I import here how the comment, type the comment, how you can install it. And once when you are done, you have to import the package and the models from package, because we will need it in all the other steps. So first we will conduct the t-test for independent samples. Why independent samples? Because we use one variable, one categorical variable with two different categories, not dependent one from each other. For example, if you have male and female participants, there is no person that can be a male and a female in the same time. So maybe it is. I will not discuss biologically, but in this data set, we don't have such case. So all our participants are split into these two categories, one of those two categories. So we will use that variable as a categorical variable, and we will use numerical variable number of views of the course. And we would like, what the hypothesis and idea is, to test, do we have any differences in gender according to the number of views of the courses. So who likes our courses more? Who actually views our courses more, female or male users? That's the hypothesis we would like to test. So we will use t-test for independent samples. It's extremely important for us to set the group 1 and group 2. Group 1 will be male participants. Group 2 are female participants. And here you can use the logic behind this is to define the group 1 and group 2, and to define that you actually use the same dependent variable, or the variable you measure, and the independent variable, categorical one, is this one. So once when you define that, this is the ResearchPy is the package we will use for the parametric tests. In my opinion, it's the best one and the easiest one to use. You have some other way to calculate t-tests and ANOVAs, but this is the fastest one, so I'm using when I can this. If you have some advanced problem or some advanced I don't know how to say, something that you need to set some parameters that are not set it by default. Maybe some other package could be better for you, but in this one is always good enough for me, was till now. So once when you calculate the t-test, first thing that you need to check is p-value. P-value is practically the lowest in statistics. So if your test and your p-value is higher than 0.05, yes, higher, sorry, then you say that something is not statistically significant. But if it's lower than 0.05, you can say that something is statistically significant. I will send you a link to some theoretical explanation of that, because now we don't have time and I wasn't sure that we will actually have time for everything, so I didn't include it, but maybe it will be very interesting to you to check. The p-value is calculated practically as a probability, and it's very logical to use it here. The discussion about that border value 0.05 is always on, but that's what we use. So that's the value we are using as a border from something statistically significant and non-significant. Also, you have 0.01 and 0.001 in some specific situations when you have lower or smaller amount of data in your data set, or when you have some very specific hypothesis. It depends on the quality of the data you have. This is the value of the t-test, and those data are more important. Here we can say that, I will back on a p-value. Here we can say that actually p-value is not statistically significant, so it means that we don't have any differences. If we look to the male and female participants in number of views of the course, we don't have any statistical significant difference. So maybe they differ. We will see that they actually do differ, but they are very close one to each other, so we cannot say that that's something that causes differences. Gender is not so important in this question. So we can conclude that following the p-value. After that, we look the t-test. This is the t-parameter, actually the how to say, the value of the test per se, and also we look at mean. You can see that mean is very close one to each other. One very important thing, here we suspect that all the variables that we will use to explain the t-test and ANOVA are distributed normally. In reality, it's not the case, so we will use the equivalent non-parametric test. It will be more clear to you once when we are done with all those things. But those are parametric tests and parametric tests, and we follow that logic when we select which test we will use for the training for this today course. But in life it doesn't work like that, so you will need first to be sure that your distribution is normal, and after that to apply some of the tests. You have also a statistical test that can actually test your distribution, Kolmogorov, Smirnov, and Wilk-Shapiro. And also it works just looking at the p-value. So I will send you a link to those tests. Practically for each numerical variable, you can apply on every numerical variable, you can apply that test, and you will have the information, is your variable close to the normal distribution or not. And after that, you can conduct pre-processing part and exclude everything what you can. So we will here conclude that, just a second, that this is not statistically significant, and we can conclude that female participants are more interested in our courses than male, but that's not statistically significant. That's very important. That explanation where you practically highlight that something is or is not statistically significant is very important here in inferential statistics. You can see like that. I leave all the questions or hypotheses and interpretation for each of the tests here in Markdown in Jupyter Notebook. Double check just questions. Okay, no questions for now. And also you can use t-test for dependent samples. I don't know how familiar are you with independent and dependent samples. Dependent samples are structured a little bit different than independent. So here practically you can imagine like you have some pre-test and post-test on the same sample. I can say like that. For example, you have some school kids and you test their knowledge in January, February, March. So you always use identical kids, identical class, but you test it through the different time periods. So you have 2 or more groups. For the t-test for dependent sample, we are focused only on 2 groups. I think that I took January and February here, to be honest. Yes. And you can test only the 2 groups, but if you want to test, for example, January, February, March, you will need to use ANOVA for dependent sample. I will back on that later. So t-test for dependent sample, this is the data set we will use. You also have it in Google Drive. And here I present, because we never cleaned those data before, this data set is first loaded here now. So we have January, February. Okay. We need to clean that. In short, we will use this shorter way, and once again, the way I not recommend it to you when you're not in hurry. As I told you, I wasn't sure that I will have time, so it was important for me only to have something clean. But if you have a huge amount of time and you're not limited, then it's better for you to use the percentile logic to clean the data. So here I detect that actually some border value is here and that I will need to exclude everything lower than that. And this is how I do that. So, okay, I exclude everything for January. I exclude everything lower than this this border value, and I can conclude I can continue, sorry, to extract the problematic or data that are defined as extreme values and outliers for February and March. So this is the way how I can do it for February. I can draw a box plot and exclude all the value higher than this one, and to leave all the lower value now with my data set. You can see that I'm using this one data set, that the one that is already clean for the January. So that's my general recommendation for you. In some previous steps, we always use the IG, the first data set, the raw data set, I can say like that. But when you are in a process of pre-processing the data, my advice for you will be to always use the latest version of your data set, the one that is already cleaned by some features. And after that, we will also clean the data for March, because we will use it later also. So this is the border value for March. Once when we clean the data, we can calculate the t-test for dependent sample. This is the easiest and the fastest function for that. Here you can see the two values, p-value, the most important one as I define, and I mentioned already, and the statistic practically is the value of the t-test and the parameter of the statistical test. Here the p-value suggests us that this is not statistically significant. So it means that practically they're very close one to each other. And if we have some differences, and we can see it here when we calculate the mean, those differences are not statistically significant. So we will not further investigate it. Here you can see the value of the statistical parameter, statistical test or parameter, test parameter. Here you can see the January and how we calculated the mean for the January and the February, and you can see that in general, in February, we have better scores on our test than in January. So on the identical sample, same sample, identical participants, we can conclude that they were much better in February. Probably they spent the January in learning, and they achieved better results, for example, in course or some other variable. It's not important which one, but the logic is important for the explanation. If you have a categorical variable with more than 2 levels, then you need to use ANOVA, and with some additional tests. We call it post hoc tests, and we can see it later why. So we will use as a dependent numerical measure, the one that we measure exactly, this value. And as a categorical value, we can use this one. So we will use this data set, the one that is already pre-processed. And the idea here is to check, actually, to test, do we have any differences following this variable student expert. Here we have three category of the expertise, I can say like that. We have students, beginners, or juniors, and experts. And we have, okay, this variable, we used it before. So our idea, I can say like that, hypothesis will be to test, do we have some differences according to those three groups. Once we are done, this is the easiest way for you to calculate the ANOVA, and I think that yes, you don't have any specific package, you already installed it earlier. And here you will have a table with the results. This is the P level. again, the most important measure we have. And this measure told us, do we have some differences in general? F value, it's the value of the test, statistical test. So here we can see that actually there is no statistical significant differences in those three groups, students, beginner, experts. But if, for example, in some cases we obtain some statistical differences, then post hoc is needed to detect where actually we have statistical differences. Here we conduct the post hoc test, although we don't have statistical differences, just to illustrate how this will function in that case. So you can input from the scikit post hocs. I think that you have already installed, yeah. So you can import that package, and we will use the latest data sets we have. As a numerical variable, we use this one. As the categorical, we use this one. And this is the method we will use as a post hoc test analysis, because you have different post hoc that you can use. It depends actually of the how to say of the type of not the type. It depends of the problem or the data you have. So those are the results we obtain. So those are the p levels, and we can see then that we don't have any p levels that is statistically significant. So there is no differences in neither of the three groups we have here. So they're very close ones to each other. So once we are done, you can also calculate the mean or some other measure of central tendencies. Here, the mean is the logical measure, because t-test suspect that you have a normal distribution. Normal distribution is related with mean and standard deviation. But if you want to check some other measure, the one that we have in descriptive statistics, you can do that. So this is just an example for mean. So you can see that the lower scores we have here in experts and the higher in juniors. So we have some differences, but those differences are not statistically significant. ANOVA for dependent samples. Similar like the logic we have above for the t-test for dependent samples. Here we have ANOVA for dependent samples. So we will see when we have more than two groups and identical users. I can say like that, dependent sample, the name said what we means. So you can check the differences. And this is, in my opinion, the best way. Again, you have another packages, another examples that you can use, and things like that. Also, it's very important for me to mention, you also have MANOVA and ANOVA. We will not cover here on this course, but you have those tests as a possibility to check, for example, if you have more than one dependent variable, have 2, 3, or 4 dependent variables, you can use MANOVA, multivariate analysis of variance. And if you have some variable that you suspect that can affect the relation between dependent and non-dependent variable, you can use ANOVA. C is a covariate, and covariate is a variable that can affect the relation between dependent and independent variables. So you have additional tests here. If you're interested in that, those tests are more advanced. So we need to import this package for the repeated measure ANOVA, and to load this data set. In this data set, we have ID of the user. We have the package. For example, you can imagine that you present identical users for different packages, and that you count the number of the sold courses. So what is repeated? Repeated is that they see different bunch of packages. All of them see every package, but not in that order. And all users see all packages. I hope that I explain you good, but I think that you can see here in table. I will just check the questions. Sorry for this interruption. No questions. Okay. So we will define data set we will use. We will define okay, subjects are the participants or users. We will define the variable that is measured, so the number of sold courses, and we will define the variable that is repeated, the client package, and it's independent variable, I can say like that. So again, we will focus our attention to P level and also to F value. Here you can see that P value is not statistically significant, which means that there is no differences in the number of sold courses according the client package we present to them, to identical bunch of clients. So it's a little bit complex, more complex than the data set we have about for the t-test for the repeated measure, but I think that it's logical. And although we don't have any difference, we can calculate the mean and just to see for all the clients and all 4 packages, what are average number of the sold courses, just to have some information. Are they far away from each other? Okay, we detect that we don't have any statistical significant difference, but again, we can see or check how close they are one to each other, those how to say, those average solid, those average values for this variable sold courses. So after that, here I will draw the line between parametric and non-parametric tests. You have also, as I mentioned, some other more advanced parametric tests. And if you want to apply some parametric tests on your data, you need to be sure that your distribution is normal or close to normal, or that you transform the data in proper way. If, for example, if you have distribution, if you have the data with not normal distribution that are not close to normal, then you can transform the data with some different transformations, like logistic transformation, inverse transformation. It depends of the data you have, and it depends of the quality of data you work with. So Mann-Whitney U, we can imagine, is like it's practically identical as t-test for independent measures, but Mann-Whitney U is used once when you don't have distribution close to normal, or you have distribution that differ from the normal distribution. So this is the example. You can see that we also here define the groups, and we defined which variable will be categorical variable, male, female, here as a gender, and you defined which numeric variable you will use as a dependent variable. So once when you define the group 1 and group 2, you can apply Mann-Whitney U on those two. To say on this case, I can say like that, and you can obtain the result. Again, p-value is the most important value, and it's the first value you will check once when you focus your attention to inferential statistics. So p-value again suggests that this is not statistically significant, and this is the value of the test per se, Mann-Whitney U statistic tests. So you know, this is not too informative for you in this case when you have non-statistically significant test, but it's good to have, and you will need to present to other people, the one who you present those results. After that, you have to calculate median. Be very careful. You can see that here we use median because those tests are non-parametric tests, and we use measure of central tendencies like median. In this case, mode no. Mode we use only in He-quadrat test. When we try to present the average value of something. So here we will group the most few courses to female and female, and we will present the medians. So this is the average median for average. I can't find some better way in English, some better word in English, but this is median for female and this is for male users. So we can here conclude that in general, female users liked our courses more. So that could be a general conclusion for us. If you want to conduct something like ANOVA, but non-parametric version of ANOVA, you will have to use Kruskal-Wallis test. And in here you will define the three groups you will use: student, junior, expert, and you will define the dependent variable that you will measure. This is dependent variable that you will measure. And you have three groups: student, junior, and expert. Here you use this function, the most the easiest function you can find and the shortest one, to compare the three groups. You calculate the p-values. Again, p-value is not statistically significant, and we cannot conclude that we have any statistical significance in those three groups of participants. And this is the value of the statistics per se. So you have median here, the value of median for the expert, junior, and student. And you can see that actually students are most interested in our courses, and the experts are the group less sensitive to our courses, which is logical, following the expertise they have. So this will be something related with the independent samples, I can say like that. But once when you are interested in dependent samples, when you use, I will mention again, the identical number of participants or the same sample, but you measure some in a different timeline, for example, in different months, or you measure something in as a pre-test, post-test, similar. So you can use this. You can use those two groups, November and December, to calculate Wilcoxon rank test. This test is non-parametric test, and it's equivalent to t-test for dependent samples. Once again, you will have p-level. This is the first p-level we have that is statistically significant. So you will see how it looks like. We have some differences that we can conclude. We will see later what kind of difference we have. And here you have the value of the statistical parameter for this test, Wilcoxon rank test. So if someone asks you what's the Wilcoxon rank test value, you will mention this number. If someone asks you about the p-level for this test, this number will be appropriate. So when you're done with this, you can calculate medians for December and November just to see which one has higher median value. And you can see that the higher value you have for November. So probably our courses or our subjects were more interested in our courses in November than in December. or value them with a higher rank. And the latest one, we have Friedman test for as an equivalent to ANOVA for dependent samples. Here you can see that we use them values for 3 months, October, November, December, and we can compare those from 3 months with the Friedman test. Again, you will check and take a look first on p-value. You can see that p-value is statistically significant. It's lower than 0.05, and here you have the value of the Friedman test. So you can see that this is actually the value of the Friedman test. If you want to calculate the median, those numbers are median, are the number of the median. So you see that, sorry, you see that the higher median value we have again in November, but we have the lowest ranks, for example, in October. So this will be the interpretation for the non-parametric version of practically Friedman is not parametric version of the ANOVA for dependent samples. Here I briefly present you the parametric and non-parametric tests from inferential statistics. We have some other tests also in inferential statistics, but it depends on the topic you would like to investigate. It depends how far you want to go with testing your hypothesis using statistics. In industry, in my job, I mostly use t-test, to be honest. Very rare I use for dependent samples, mostly for independent samples. But it can be useful, very useful, no matter what you investigate and how, or do you use it in academy? Do you use it in industry? I think that you have a space where you can use that. Here I will briefly mention correlation and regression. As I told you, regression is a modeling technique. So following that logic, regression, linear regression is a part of machine learning, is actually machine learning technique. And we will not cover this on this course, but I will send you. It's okay for me. So when we are done, I will edit the code and send to the host the edited version of the codes with some additional links, for example, for playing, testing, things like that. And also I have some open projects that I created for my students, and I play with the project too. So I can share it with you if you want. You can also text me on LinkedIn, just not to forget to say, and I will share with you on all the material from my GitHub. Just to check, do we have some questions? And so sorry because of my voice, because I'm very sick with the temperature and I hardly speak, so sorry for that. But we're close to the end. So correlation and regression. Correlation is actually a technique that you can use to see are your variables or features related. I can say like that. If you want to test, can you predict some values following the values in one variable, correlation will not be good enough for you. So correlation is a good once when you want to test, do you have any relations between features and variables? If you have, you can go further with more advanced analysis. If you don't have, be careful. If you go with regression and other analysis, you can do that. It's not forbidden. But be careful with interpretation, how you can interpret if you, for example, detect that you don't have relation between two variables, and after that you detect that one can predict the values of the other. So that suggests us that we have some problems in features. So I will back on correlation. This is, you can input from CPy Pearson correlation. Pearson correlation is mostly the most popular correlation method, and we use it almost on all cases. Pearson is used mostly when you have two numerical variables, and you can here load the data set. We have specific data set for correlation and regression. Here you can see that we have the feature how many times you open the link, and the other one a number of hours you spend on course. So we can check the correlation between those two variables, and we will have two numbers. One is p level. In this step and in this analysis, we don't look at the p-values. P-value is not so informative measure here, but the value of correlation will inform us, is our correlation strong, very strong, or is it low correlation between some variables features. So here, when we conduct the Pearson R correlation for those two measures, we can say that actually we have solid correlation between those two features, and we can present it on scatter plot. Scatter plot is plot that you will use very often in correlation and regression testing. So scatter plot is the plot with the dots. You probably saw that. Here in correlation, while we're testing while we calculating the correlation between two measures, you can see that scatter suggests us what we saw already. This correlation is solid. We have some correlation between two measures, but we have a lot of extreme values and outliers. So if we want to have stronger correlation, some data preprocessing is needed again. In a case when you, for example, have one variable that is not strictly numerical, or to be more precise, is a rank variable, you can use Spearman correlation method. It's something similar like Pearson, but it's not so rigid. I think that's the word. When you apply it, because it doesn't suspect that you have both variables numerical normally distributed. So we will conduct on the same two variables Spearman correlation, and you can see that actually they're very close, Spearman and Pearson correlation, which suggests us that Pearson is good enough for us and can interpret the results we have. But definitely, if we want to have some higher correlation, we will need to clean our data in details more. So you can calculate correlation between all numerical features you have in data set, no matter how much cases you have. And always, my advice for you will be that you can always, and you have to always to calculate, okay, the parameter for correlation, small r is the sign for the correlation, and always present it visually with scatter plot. It's very important for those who are reading your graphs and your statistics to have the visual presentation for this. The same question is for linear regression. Also, you need to present it both visually and to give the number or the statistic for the regression. You have a higher capital letter R is the letter you will use to present the regression model value. So regression, if we go, this is linear regression, it's very simple linear regression with only two variables. In regression, you can use multiple variables. It's multiple linear regression. You can use, in this case, we use two numerical variables, but you can use also, you can conduct the regression analysis once when you have one numerical variable and one categorical variable, or when you have one binary variable. In that case, this is logistic regression. When you have a lot of multiple regressions, I already mentioned, this is a multiple linear regression. And if you want to go in some more advanced regression analysis, that's also possible. So here it's very important for us to define the x value and the epsilon value, and to define the x-axis and epsilon axis, what values we have on x and what we have on epsilon. On x-axis, we almost every time present the measures, features, the feature that we will use as a predictor. And on epsilon, we present the variable with the name criteria, and we actually, that's the variable and the feature that will be predicted with the measures of x. So here we presented, I can remember how many times you open the link is on x value, and how many times you view course is on epsilon value. In logically following just a pure logic, that those two measures could be related, and the one can predict another. If you open some link to the course more times and more often, the greatest possibilities that you look that you will also look that course. So on x value we present the predictor, and epsilon the criteria, the feature measure that will be predicted. And this is the regression line, the one that we will draw just to have some trend, to observe the trend or linearity in that data set we're using. Those data points are actually measures from our data set. So here you can see that actually the regression score is very low. It's not very, it is. It's low. So the prediction will. I cannot say that we can predict very precisely the values on epsilon axis following the values on x-axis. But what we can see that maybe if we clean the data, the regression score will raise. And in this case, you will again need to clean the entire data and to conduct the pre-processing part of the analysis once when you are here at the end and you want to conclude something about linear regression. So I will stop here. I wasn't sure how much time we will have, so I just put all those things here. We have more. You have more parametric and non-parametric tests. You have more predictive analytics methods, and I will send it to you. I will not forget that, but if you need some additional materials, please let me know. It's always okay for me to share everything with you. If you need books, tutorials, no matter what, just text me LinkedIn, I will share you. And that's it. I think if you have
Sorry for interrupting. You have 45 minutes left.
Yep.
So if you want to share anything else, you can, you have time.
Well, I didn't prepare because
okay.
I wasn't sure how much time we will have.
Yeah, okay.
But I will read the question, and please, we are here together, so please send question on chat. I will be till the end with you, just to see where I stop. Which feature selection do you propose for numerical outputs? Okay, I will back just to open. Could you please share a link with documentation? I can share a link with documentation. We already shared the link. If you think about documentation from this course, the one that we are using now, we already share it. But I will send you additional materials. I will send it to host. Just this disable. How disable?
Can you put it in your folder so we can share it all together?
Yeah, they have already this code.
Yeah, okay.
Okay, sorry. Now we will send it. No worries. How often do you use statistical inference in your regular workday? To be honest, I'm not using it very often. That's the honest answer, especially now because I'm leading the team, so I'm not using technical things at workday at all. But once when I am doing more statistic, not often. In business, actually, when they don't see the value in statistics, they stop once when they have some information about descriptive statistics. If the clients want something advanced, we then transfer our attention to machine learning, and we create some machine learning models. But inferential statistics in everyday work, not so often, to be honest. No, question about the limits of the data file size and the records which Python can process. No, in my opinion, there is no limits. Only limitation that you can have is in Jupyter Notebook. If you have extremely large amount of data, then my recommendation for you will be to use a PyCharm as an interface for coding, not Jupyter Notebook. Jupyter Notebook we're using in analytics because it's more presentable. I can say it like that. And it's more beautiful for presentation and easier to present. So that's why we are using Jupyter Notebook. But if you have extremely large amount of data from I don't know, from servers and things like that, PyCharm will be a better option as an interface for coding. For development machine learning model, which feature selection do you propose for numerical inputs? Good question. For machine learning, I can say how we work that. The first selection is always expertise. It's always expertise. So we select the features that we suspect that can be very influential. But practically, my advice will be to calculate the correlation for all numerical feature. I see. For Concourse Maneuver Shapiro will be added. No worries. Where I stop? For machine learning. So the first thing will be our expertise, and the second will be correlation, to calculate correlation between all the measures. I literally put all the numeric measures and calculate the correlation between them, where I found that the correlation is high or it's solid. We use those features for machine learning later once when we create random forest and things like that. So those two methods we are using for now, and I think that those two methods are in generally mostly used in industry, to be honest. I know that in academy but I will. I'm not following so much the academic work in that field, so to be honest, I'm not reading the papers. I know that they published practically at day level new methods for everything. So maybe in academy you have some better solutions, but in industry those two solutions we're using mostly. Theoretical minimum size on the rows. You can find some information about 32, yeah, in some literature, but in general, 100 is something in industry that around 100. I'm not sure, but that's the smallest in my opinion and in my previous practice. That the smallest amount of the rows you can have, and the smallest sample that you can use, because in industry it's very specific situation. I think that yes, in theoretical 32 or 34, I can remember the exact number, but I can check. But in general, when we see the data set smaller than 100 cases, we are not using for ML in industry. So do you have some other questions? Okay, I think that we don't have any questions about this. So I can leave you and you will have a little bit more time till the next sessions. I will send you everything what we discuss here, and please let me know if you have any questions on LinkedIn. I will answer, or also you can contact the organizers if you need a mail or something like that for additional questions. Will we get a recording of this? The organizers will respond. Probably yes.
Isidora, we are very glad to have you as the tutor at our conference, and this was very interesting. And I would also like to thanks everyone for joining us.
Thank you, and so sorry for this awful voice, but I hope that you followed everything.
Yeah, it was perfect. So I can now end the meeting.
You can. I will send you everything on email.
Okay, thank you. Goodbye.
Bye.